A cognitive bias is a systematic pattern of deviation from rational judgment. These deviations occur when individuals process and interpret information in their environment. Cognitive biases emerge from various mental processes that simplify information processing. The human brain receives approximately 11 million bits of sensory information per second. Conscious processing capacity handles roughly 40 bits per second. This disparity necessitates the development of mental shortcuts. These shortcuts are heuristics. Heuristics reduce cognitive load but introduce predictable errors in judgment. Confirmation bias is the tendency to search for, interpret, and recall information in a way that confirms pre-existing beliefs. This bias operates across three distinct phases. The first phase involves selective exposure. Individuals preferentially seek information sources aligned with existing viewpoints. The second phase involves biased interpretation. Ambiguous evidence receives interpretation favorable to prior beliefs. The third phase involves selective recall. Memory retrieval favors information consistent with current attitudes. Studies conducted between 1960 and 1998 documented this pattern across 214 experimental conditions. The effect size remained consistent across diverse subject populations and content domains. Anchoring bias describes the tendency to rely heavily on the first piece of information encountered when making decisions. This initial information serves as a reference point. Subsequent judgments adjust from this anchor. The adjustment process typically proves insufficient. Research conducted in 1974 demonstrated this effect through numerical estimation tasks. Participants estimated the percentage of African nations in the United Nations. A random number was generated by spinning a wheel. Participants then adjusted their estimates from this arbitrary starting point. The median estimates varied by 15 percentage points based solely on the initial anchor value. This effect persists even when anchors are obviously irrelevant to the judgment task. The availability heuristic is a mental shortcut that relies on immediate examples coming to mind when evaluating a topic or decision. Events that are more memorable receive higher probability estimates. Memorability correlates with vividness, recency, and emotional impact. A study from 1978 asked participants to estimate the frequency of various causes of death. Deaths from dramatic causes, such as tornadoes and homicides, received systematically inflated estimates. Deaths from mundane causes, such as asthma and diabetes, received deflated estimates. The actual statistical frequencies showed the reverse pattern. Media coverage patterns strongly predicted the direction and magnitude of estimation errors. The Dunning-Kruger effect is a metacognitive bias in which individuals with low competence in a domain overestimate their ability. Conversely, highly competent individuals slightly underestimate their relative competence. Research published in 1999 examined performance across domains, including logical reasoning, grammar, and humor. Participants in the bottom quartile of actual performance estimated their performance at the 60th percentile on average. The discrepancy between actual and perceived performance decreased as actual competence increased. This pattern results from a dual burden. Incompetence not only produces poor performance, but also prevents recognition of that poor performance. Skill development in a domain simultaneously improves performance and calibrates self-assessment accuracy. The sunk cost fallacy is the tendency to continue an endeavor once an investment in money, effort, or time has been made. This continuation occurs regardless of current costs exceeding current benefits. Rational decision-making evaluates only future costs and benefits. Past investments are irrelevant to optimal future choices. However, psychological commitment to past investments influences ongoing behavior. A 1985 study presented participants with a hypothetical scenario involving a failing research project. Participants who were told they had already invested 90% of the budget showed greater willingness to complete the project. This preference persisted despite identical information about future costs and probable outcomes. The effect scales with investment magnitude and personal responsibility for initial decisions. The framing effect occurs when different presentations of identical information produce different decisions. A study from 1981 presented a disease outbreak scenario. 600 people would die without intervention. One treatment option was described as saving 200 lives. An alternative framing described the same option as allowing 400 deaths. 72% of participants selected the first framing. Only 22% selected the second framing. The objective outcomes were mathematically identical. Positive framing emphasized gains. Negative framing emphasized losses. Loss aversion amplifies the framing effect. Humans exhibit stronger psychological responses to losses than to equivalent gains. Hindsight bias is the tendency to perceive past events as having been more predictable than they actually were. This bias operates after an outcome becomes known. Individuals believe they would have predicted the outcome in advance. Memory reconstruction alters the recall of prior beliefs. A 1975 study asked participants to estimate probabilities of various outcomes before historical events occurred. After outcomes were revealed, participants recalled their earlier estimates. Recalled estimates systematically shifted toward the actual outcomes. The magnitude of shift averaged 23 percentage points across conditions. This bias complicates learning from experience. Overestimating past predictability reduces motivation to improve forecasting methods. In-group bias is the tendency to favor members of one's own group over those in other groups. This preference manifests in evaluation, resource allocation, and information processing. Minimal group paradigm experiments established this effect. Participants were assigned to arbitrary groups based on meaningless criteria such as preference for abstract paintings. Even with these minimal conditions, participants systematically allocated more resources to in-group members. Neural imaging studies show increased activity in reward processing regions when viewing in-group faces. The effect strengthens when groups compete for limited resources. Historical intergroup conflict further amplifies bias magnitude. In-group bias is the tendency to favor members of one's own group over those in other groups. This preference manifests in evaluation, resource allocation, and information processing. Minimal group paradigm experiments established this effect. Participants were assigned to arbitrary groups based on meaningless criteria, such as preference for abstract paintings. Even with these minimal conditions, participants systematically allocated more resources to in-group members. Neural imaging studies show increased activity in reward processing regions when viewing in-group faces. The effect strengthens when groups compete for limited resources. Historical intergroup conflict further amplifies bias magnitude. In-group bias is the tendency to weigh recent events more heavily than earlier events when forming judgments. This temporal weighting affects memory, prediction, and evaluation. Financial decision-making research demonstrates this pattern. Investors extrapolate recent market performance when forecasting future returns. A 10-year period of above-average returns increases average return expectations by 4 percentage points. Historical base rates spanning longer periods receive insufficient weight. Performance evaluation studies show similar patterns.
Annual performance reviews disproportionately reflect final quarter performance. Events occurring 9 to 12 months earlier receive approximately 40% less weight in final evaluations. This bias interacts with the availability heuristic, as recent events are also more easily recalled.